Okay, in your homework, I'm going to give you 5 questions to do. I'm going to give you, in 3.1, I'm going to give you, for the assignment for this week is 30, 31, 38, 47, and 54. The first 3, 30, 31, 38, are just the review of finding critical numbers. And you can look at the assignment that you did before spring break. Kind of just remind us what we're doing. Critical numbers are really important. But then the last two are the important ones in terms of the assignment, 47 and 54. So I'm going to put an example of each. And this is what we're really going to be focusing on for the next couple weeks. And then we'll do the word problems called optimization. So I'm going to do 2 examples, example 1 and example 2. And the first example is for number 47, which we're going to do now. And then I'll put up a second example for 3.1 for an example for 54. Okay, so the question is, and this is the idea, is if we have a function x to the third minus 3x squared minus 9x plus 10, and we want to find the absolute max and the min on the interval -2 to 4. Now, just to be clear, I usually write it in the regular algebra notation. Your textbook writes what's called interval notation, when the brackets mean the same thing as this. So this just means -2, and that just means 4. Just in case you've never seen that before. So don't worry if you haven't. Just realize that sometimes the book uses that. Now, remember what we have to do. We have to remember. Okay, there are only 2 places to look from the first the introduction to this. The only 2 places I have to look are the critical numbers and the endpoints. So first, make an observation. I only need critical numbers and endpoints. Now, what I'm going to do is I'm going to find out those critical number and the endpoints, and those will be x values. And then I'm going to put those x values back into this original equation to get the y values, and then once I do that, then I'll be able to find the biggest y value and the smallest y value. So first off, endpoints, -2 and 4. -2 and 4. There's always going to be one endpoint on the left and one endpoint on the right. Now, when you go to find critical numbers, there can be tons of them. There could be 100 of them, but they're normally not. There's normally 1, 2, or 3. As a matter of fact, for this class, it's either going to be 1, 2, or 3. There could be 0. The function could always be going up or always be going down and never actually change, right? So when you go to find the critical numbers, which is the calculus part, don't presuppose how many they're going to be. Well, you could presuppose there's going to be 2 or 3. 1, 2, or 3. I could put 4 more, I could put 0, but generally it's not interesting if there isn't some critical numbers. So, and if there's so many, it's like, what we're going to do is we're going to say that the endpoints are -2 and 4. So those are if you remember from the previous lecture, those are I have to check those points, and then I also have to check the critical numbers. So let's now first step. I think I told you there's kind of 3 major steps here. First step, we need to find the critical numbers, and then once we have our list, then first step is we have to take the derivative, and then we're going to use that derivative to solve an equation to get the critical number. So actually, there's 2 or 3 steps there. And then the last step is to then once we have our list, to put all the numbers in. So I know it could be -2 or 4, but then I have to find the critical numbers. Well, okay, so let's take the derivative. So the original equation was f of x equals x to the third minus 3x squared minus 9x plus 10. So first step is to take the derivative. And that's the calculus, and that's why it's a calculus question, obviously. And we know how to do that. That's a pretty easy derivative. Now, as a matter of fact, none of these steps here are that hard. It's just that it's just that it takes a while. It's not something that happens immediately. So now that I have the derivative, how do I find the derivative? I have to find what's called the critical numbers, and that is when the derivative is 0 or undefined. Now, why did I just write 0? Because notice this function is never going to be undefined. The derivative, whenever, remember, the only thing we have to worry about is dividing by 0, so don't worry about that. That's not that big of a deal. So 3x squared minus 6x minus 9. So the first step is to take the derivative. That's the calculus part. Then the second step, once we've taken the derivative here, we have to solve this equation. So now I got to go back and we have to do some algebra. You have to remember. So remember, I usually factor out the common factor. Then again, you got to go back to algebra 1, back to middle school. And notice that this can be factored into x minus 3, x plus 1. Now if you need to, just FOIL it back out. First times first, plus 1 minus 3 is minus 2. A negative times a positive is negative 3. So remember what we know then is x is 3 or x is negative 1. Those are called critical numbers, and that's what you're going to be doing on the first 3 homework. And just to be clear, on the first 3 questions on your homework, that's it. You're done. But that's not really what we want to be doing. We want to be finding what is the highest and lowest point of the y values here. So I got to add 3 and negative 1. Now, if you have a calculator, this is pretty easy. But let's assume we don't have a calculator. You're at home this now. See, in class you wouldn't have a calculator for this part, okay? But since you're at home, okay, use a calculator. What do I care at this point, right? So let's look at this here. So what we want to do then is we have to now put all of these points into the original equation. So I put negative 2 in, I get negative 8. Negative 2 times negative 2, or negative 2 squared, is positive 4, but a positive 4 times a negative 3 is negative 12. And then a negative 9 times a negative 2 is positive 18 plus 10. And what do I end up with? Okay, that's negative 20. So negative 2, so what, 8? If you add that up, you get 8. So that's one possibility for being, remember, these numbers are the big dogs here. These are the ones that we have to use to find the actual max and min. So I'll put 4. Now this gets a little trickier. 4 to the third is 64. 4 squared is 16 times 3 is 48. Got to carry 1. Minus 36. Plus 10. And again, notice that this can actually be a challenging thing for some students. So let's add those up. Let's see here. Negative 48, so negative 16, so negative 20, so negative 10. If I add those up, I get negative 10. And again, I don't want to dismiss this. That would actually be challenging without a calculator, right? So 3, well, for some people, okay, it'd be challenging. For some of you, probably good at adding stuff up. 3, that's what, 27? That one, at least this one's kind of nice, because you get negative 27, positive 27 minus 27. Oh, wow, another 27? Plus 10 is what, negative 17. So you get negative 17. And then the last one, negative 1. Just be careful with the negative signs. Negative 1. Negative 3. Remember, because the negative 1 squared is positive 1 times negative 3. Negative 1 times, so positive 9. Positive 10. 15? Is that right? 15? I think that's right. Okay, so what do I have for my choices? So just, I'm going to put the choices over here a little more. So x And then the f of x choices, this is obviously y. So the endpoints were at -2 and 4. The critical numbers, now remember there's always a left endpoint and a right endpoint, and then there's critical numbers, and there can be lots of critical numbers. There can be 0 to infinity critical numbers, but there's usually going to be between 0 and 4, and I think usually for me it's 1, 2, or 3 critical numbers. So there's critical numbers. In this case there's 2 critical numbers. So the endpoint, the y value is 8. The endpoint on the other side is the y value is -10, and then we get -17, and then 15. And then you literally look. That's the smallest, and that's the biggest. But we don't say that. We say the absolute min is -17, and the absolute max is 15. Now sometimes we write it like this. You could do f of 3, and you'll notice your textbook does this, and then f of -1 equals 15. But just to be super clear, the -17 is the minimum, and the 15 is the maximum. Notice we don't have to graph it to answer the question. So, this is an example of number 47 in your homework. Remember, the first 3 are just critical numbers. After I put this one up, I'm going to put the next one up, which will be one like 54, which will be the last question. You'll have 5 questions in your homework. The first 3, 30, 31, and 38 are basically just find the critical numbers, and you'd actually be done here when you find the x values. And then the last 2 questions, number 47, will look like this one, and then I'm going to do an example right now of 54. And that actually, the cool about 54 is we'll actually discover the idea of having a undefined derivative. Okay.